All right, so, oh, I know what we gotta do. This is for Tamra. Ba-ba-ba-bum. Okay.
I'll play Hangman.
Okay, we are going to reconstruct the map of the nervous system from scratch. It starts with what's down here, our three components. Receptors, control center, and in this case specifically, if it is the nervous system, the control center is what two organs? Brain and spinal cord. And then out here, we're gonna have effectors. Okay, what are our three types of receptors?
Special.
Visceral, special, and somatic. How does this information get from the receptors to the brain and spinal cord?
Afferent.
An afferent or sensory neuron. And then we're going to send out what kind of a command? Or what kind of a neuron is going to take that command from the brain and spinal cord?
Efferent neuron.
An efferent or
Motor neuron.
motor neuron. And we immediately split.
Somatic.
So we have two branches of our motor division. The first is our somatic, and the other one is the autonomic nervous system. What is the effector for the somatic nervous system?
Skeletal
muscle.
Skeletal muscle. And then our autonomic nervous system just can't be simple. It's got to create two branches. They are parasympathetic and sympathetic nervous system. And then they are going to have how many effectors? Four, which are cardiac muscle,
Skeletal.
Smooth muscle.
smooth muscle, adipose,
Glands.
and glands. All right, adipose and glands. Okay, so that's how I play with it. Rather than just having a blank, it's just like just start drawing it over and over, and you'll get it down. You guys already seem to have, well, how many times did I drill this into your head in anatomy? Better.
We had our test 3 different times.
What are you gonna remember 5 years from
Was it
now?
only 3 times?
It was only 3 times,
The
but it was
map
3
of
times.
the nervous
Okay, but who
system. Well, you get to use it again, and you didn't have to spend a whole lot of time learning it.
This is a religion in this house. It is a cult.
Will you ever need to know that it's the peripheral nervous system?
Oh yeah. So what do we call the brain and spinal cord?
Central nervous system.
Central nervous system. What do we call everything outside the central nervous system?
Peripheral.
That is your peripheral nervous system. Yes. I forgot those two little details. Okay. And
It didn't miss any.
yeah, you guys pretty comfortable with different parts of the neuron now that we've been through it? All right. And we covered this. Okay. What are the attributes of a local potential?
Short.
Okay, it's only for short distances. Why?
Because it does.
The D word. What's the D word? It is
No.
No, not D.
D-E,
Degradation.
Degradation.
decremental.
Decremental.
Because decremental means that it gets
Weaker over time.
weaker, because you're going to lose some of those ions going out those leak channels, and it gets weaker and weaker. And it also responds to
Force.
baby.
Just force.
The strength of the stimulus. So it is decremental and it responds to the strength of the stimulus. So it's not good for long distance signaling in the body. When we get to, what's the little structure where we make the decision? The axon hillock. And the axon hillock is going to have to integrate all this information together. So it's going to be, this neuron could be receiving two types of stimulation. They could be either excitatory postsynaptic potentials or inhibitory postsynaptic potentials. To create an excitatory postsynaptic potential, I will open up what type of channels?
Sodium?
Sodium, because that's going to do what to my charge, my resting membrane potential? It's going to make it more positive and make it go closer to, what's that value? Threshold. How could I create an inhibitory postsynaptic potential? Open up potassium channels or chloride. Then that would make it more negative, hyperpolarized the membrane, and make it less likely to create an action potential. All right, so we have to, let's practice this. Generation of an action potential. So, resting, we're gonna do, ugly as hell, but it is functional. So, we have 4 steps to any action potential. What is happening at step 1?
Reaching threshold.
How?
Sodium channels open.
We have a stimulus which opens up sodium channels and brings this neuron to threshold, a value of
Negative.
minus 55, because we start off here at minus 70, we go to minus 55, and what event happens? What physically happens inside the neuron when we hit minus 55?
All or nothing.
We open up voltage-gated sodium channels, causing the process called depolarization. We depolarize to roughly plus 30, and what happens at plus 30? Close the sodium channels,
Open.
open the potassium channels.
And we repolarize.
And that is the process of repolarization. But those doggone potassium channels are just a little slow to respond, so what briefly happens?
Hyperpolarization.
Hyperpolarization until the potassium channels finally close, and then how do we get back here to RMP? Sodium potassium pumps in your leak channels bring you back to resting membrane potential. So those are our 4 steps to generation of an action potential. And the attributes, if we can create an action potential, what are the attributes of an action potential compared to a local potential?
Greater.
It's called blank, blank, blank.
All or nothing.
All or nothing. We're either gonna hit it and it's gonna go to 100%, or it's not going to happen at all. We're just gonna kill that information and we're going to ignore it. And if we do create it, does anything happen to its strength as it propagates down the
No.
axon?
It's
No.
not decremental.
Correct. It is just like dominoes. You hit that first domino and it's gonna go all the way to the end no matter what.
What is
There
degradation?
are, what?
What is what do you say?
Degradation.
Degradation is when something degrades and gets weaker or breaks apart.
Oh. So that kind of is. A
Kinda.
local.
Yeah,
The waves aren't breaking.
a local potential kind of degrades. You could think about decremental as a kind of degradation, but decremental is a better term to use. There are certain things which alter the speed at which that nerve impulse is propagated down the axon. The first is
Diameter.
diameter of the axon. Who's going to be faster?
Large.
Large diameter compared to
friction.
small. And then the second component, which alters the speed at
Quantity.
which that is myelinated versus unmyelinated. If it is unmyelinated, the propagation is termed what down the axon? Continuous conduction. And if I have myelin on that axon, then that type of propagation is called saltatory. Remember, salty dog, saltatory. All right. And then we talked about, what do we call the process of coming to a conclusion? So you're at the synapse, and now this one neuron has 1,000 other neurons innervating it. What do you call that process of this postsynaptic neuron coming to a decision about how to respond? Okay, it is neural integration by the process of summation. So we're going to basically count up the number of excitatory postsynaptic potentials and the number of inhibitory postsynaptic potentials, and whatever we have more of wins. So if we have more inhibitory, what are we going to do with that signal? Kill it. We're going to not pay attention to it. If we have more excitatory, then we're going to
All or nothing.
make it happen. Okay, I didn't talk about the gates, but I think these are pretty common. Where would we find, on a neuron, where would we find chemically gated channels?
Oh.
Oh, wait.
Are you talking about?
Body and the
Yeah, on the dendrites and the cell body. So think about your taste buds. Those are chemically gated channels, right? Think about that postsynaptic neuron which receives neurotransmitters. Those neurotransmitters are chemicals, so they're going to bind to a chemically gated channel. So your dendrites and your cell body. And then voltage gated channels are only found on the axon. That's what's responsible for propagation. We have mechanically gated channels. So think about tactile receptors, where you're going to find a mechanically gated channel that depolarizes based upon deformation of the plasma membrane. On the dendrites again, as far as where you're going to find these located on a neuron. All right, and you guys are comfortable with depolarization, repolarization, and hyperpolarization. Okay, we did local potentials. We did the steps of an action potential. And we talked about how an action potential is different. Okay, what causes, if a neuron will not respond, no matter how hard you stimulate it, why is it unable to respond?
Too many at once?
Your sodium channels are already busy. So if your sodium channels are already busy, that's your absolute refractory period. And if they're not reset, I don't care how much you stimulate it, it can't respond because the sodium channels are either inactivated or busy. And it takes opening of sodium channels to create a depolarization. Then here, I could create another action potential, but it's going to be harder
Because you're farther away.
because I'm hyperpolarized. So that's going to be my relative refractory period. And then there's your lidocaine, blocks voltage-gated sodium channels. We talked about conduction. We talked about the different types. And we actually, did we just practice this? Yeah, we just practiced this. So we don't need to do that again because you guys got that down. We talked about inhibitory. We talked about integration and summation. Two different types of summation on a neuron. This is what you were referring to earlier. So if I am innervated by more than one neuron whose axon terminals release neurotransmitters that are excitatory both at the same time, we call that spatial summation. If it is just a single neuron firing off in rapid succession, we call that
Or temporal.
temporal summation. So temporal having to do with time. Rapid fire, 1. Spatial, will have more than one space being taken up by more than one neuron on that axon hillock or on the soma. Okay, oh, and then neurotransmitters, okay. So let's get this off here so you're not watching.
No, leave it up there. We'll get it right.
What neurotransmitter is a feel-good neurotransmitter that helps you with moods? It's involved in addictions,
Dopamine.
and it is altered by medications for antidepressant.
Serotonin.
That's gonna be serotonin. What is the neurotransmitter released at all neuromuscular junctions?
Acetylcholine.
Acetylcholine. What is the neurotransmitter that helps to block pain signals?
Opioids.
Opioids. What is the neurotransmitter that conducts pain signals?
Oh, we just did this today.
Substance.
Yeah.
Pain signals.
Oh.
Substance.
P.
P. Substance
Oh.
P transmits pain
Substance
signals.
pain.
That's how I always remember is like substance P, pain.
Your chair.
What two
stand
neurotransmitters would increase heart rate, increase blood pressure, cause the bronchioles to dilate, and would shut off digestive processes? Adrenaline, epinephrine, and norepinephrine. What neurotransmitter is involved in movement coordination and emotions? That is dopamine. So remember Parkinson's disease, movement
Parkinson's
coordination.
dopamine.
Which
Parkinson's
one is your
is not
major
dope.
excitatory neurotransmitter in the brain?
Astral.
Can you ask it again?
Glutamate. And then what is the major inhibitory neurotransmitter used in the brain?
GABA.
That's GABA. So think tequila and GABA. What is the name
Sounded
of
confident too.
the condition where you have abnormal, disorganized electrical activity in the brain that spreads like a wave?
Multiple sclerosis?
That is epilepsy
Oh.
or seizures. Epilepsy or seizures. What happens with multiple sclerosis, MS?
The
You lose
neurons.
coordination.
Demyelination of the axon. And if you
Demyelination.
demyelinate the axon, then you're going to basically cause it to short circuit. And you're going to disrupt any sensory signals coming or motor signals leaving the body. And that's it on that chapter. Okay, so one of the main things, what is the main advantage of a nerve plexus? 3 words.